Okay, so in this video, here's another way of solving those altitude on hypotenuse problems other than drawing the three separate similar triangles, which can be very time-consuming and tedious. So another way would be to think of these problems. There are basically two different ways to solve these altitude on hypotenuse problems depending on the given information. Okay, so I'm just going to label the diagram at the left because this is kind of like the general diagram of what an altitude on hypotenuse problem looks like. You have an altitude that's drawn to the hypotenuse of the right triangle. Once in a while they'll flip the diagram around on you, but for the most part this is what it looks like. So I'm going to label this segment here. I'm going to call that, I'm just going to abbreviate it because that's our altitude. So I'm going to abbreviate that as altitude. And then this is the hypotenuse of the large triangle, so I'm going to abbreviate that as HYP. And then the hypotenuse is being split into two pieces, and it really doesn't matter which piece you label part 1. So I'm going to call it hypotenuse part 1, and this is hypotenuse part 2. The altitude is splitting that hypotenuse into two pieces, so I'm going to call it HP1 for hypotenuse part 1, HP2, hypotenuse part 2. Then we know that this side is a leg of the large right triangle. So I'm going to call this leg 1 because it's next to hypotenuse 1. I'm going to call this guy leg 2 because it's next to hypotenuse piece 2. Okay, so now I have all the segments in the diagram labeled. So here's the first type of problem it could be. The first type of problem that this could be is when you're either given the altitude or you're trying to find the altitude. So I'm just going to make a little note here to use this when you're given the altitude or you're trying to find the altitude. Okay, so if you're either given the altitude or trying to find it, then you're going to put whatever the altitude is, or if you don't know it, you're going to just put a variable there. You're going to put that in your means position of your proportion. So the altitude would go in your means. Then in your extremes, you're going to put the two hypotenuse pieces. So hypotenuse part 1 and hypotenuse part 2. And then you're going to go ahead and cross multiply and solve it. So you use this type of proportion when you're either given the altitude or you're trying to find it. Now, the second type is if you're given a leg or trying to find the leg. And there's two different ways of thinking about it because I know that there's two different legs. So really essentially the last two, so 2 and 3 are the same exact thing. It's just I'm going to show you, for instance, if you were given or trying to find leg 1 or if you were given or trying to find leg 2. But really they are pretty much the same thing. So you're going to use 2 and 3 when given a leg or trying to find a leg. So let's just say, for example, that it's leg 1 that you're either given or you're trying to find. So that's going to go in your means position. Whatever leg you're either given or trying to find, that goes in your means. In your extremes, you need to have the entire hypotenuse of the large right triangle. And then whatever hypotenuse piece is next to that leg, that needs to also go in your extreme. So if it's leg 1, notice that hypotenuse piece 1 is next to leg 1, so that needs to be in your extremes. Now the only difference with leg 2 would be which hypotenuse piece you use. So let's just say you're given or trying to find leg 2, then that would go in your means. The entire hypotenuse would go in your extremes, and then hypotenuse part 2 would go in your extremes because that's the piece of the hypotenuse that's next to your leg. Now all you need to really do is just memorize one of each, the altitude one and the leg one, and then you should be good to go. And then you can just go straight to setting them up without having to draw the similar triangles. So keep in mind, where do these proportions come from? They do come from the similar triangles. This is just a quick way to memorize it rather than drawing out the triangles and then trying to label it from there, because that, like I said, can be very tedious and time consuming. So let's try to use these proportions to do a couple examples together, and then I'm going to have you try some examples on your own. So if we look at this first example, the first thing I want to determine is it an altitude problem or a leg problem? Because I don't know anything about the two legs of this right triangle, large right triangle, it is an altitude problem. Notice the altitude is what we're trying to find. So I'm just going to make note that's an altitude problem. So recall that the altitude has to go then in our means position, so the x is our altitude. And then the two hypotenuse pieces are going to go in our extremes. And now you're just going to go ahead and cross multiply, and you're going to end up getting a quadratic. So x squared equals 64. Take the square root. Normally we would put a plus or minus in front, but we know that we don't need to for these types of problems because we can't have a negative side length. So you always want the positive answer. So the altitude would have to be equal to 8. In example 2, let's determine if it's an altitude or a leg problem. Notice that we don't know anything about the altitude, so therefore this is going to be a leg problem because we are given this leg is equal to 6. So if it's a leg problem, we put the leg in our means position. The entire hypotenuse goes in the extremes, and then the piece of the hypotenuse that's next to the leg also goes in our extremes. Now when I go to cross multiply, I get 2x equals 36, and then if I divide that by 2, I get x is equal to 18. That's my final answer. Notice these problems are a lot quicker if you have the proportions that we labeled above, if you have those memorized. These will be very easy problems for you. Okay, 2 more together, and then I'm going to have you try the rest on your own. So number 3, this would be a leg problem because we are given, or actually we're not given, we're trying to find a leg. So that leg is going to go in our means position. The entire hypotenuse goes in our extremes, and then the piece of the hypotenuse that's next to that leg is going to go in the extremes. Cross multiply, I get x squared equals 35. I can't simplify the square root of 35, so that's going to be my final answer for x, the square root of 35. Example 4, this would be an altitude problem because I don't know anything about the two legs. So I'm going to put my altitude in my means position. And then the two hypotenuse pieces go here. I only know one of the hypotenuse pieces is 4, but I need the other one. So we kind of have to do a little bit of subtraction here. We know the whole thing is 13, and if we subtract 4 from 13, we get this hypotenuse piece is 9. So just be careful of that. Sometimes it doesn't give you every single piece of information you need. You may need to find some of it on your own. When I cross multiply, I get x squared equals 36. And then take the square root, and you get x equals 6. Okay, so now what I'd like you to do is turn to the next page, try the next page on your own, see if you can get those answers, and then once you're finished, you can go ahead and press play to check your answers. So pause the video now. Okay, so hopefully the first thing you did is determine whether it's an altitude versus a leg problem. So example 5 was an altitude problem, so I had the proportion 3 over x equals x over 9. When you cross multiply, you get x squared equals 27. Take the square root and make sure you simplify that. So the final answer, x equals 3 square root 3. Number 6 was a leg problem. The proportion you should have is 12 over x is equal to x over 9. Cross multiply, simplify the square root, you should get x equals 6 square root 3. Example 7 was a leg problem, so I had 12 over x equals x over 3. When I cross multiply, take the square root, I got x equals 6. Now number 8 is slightly different. It is a leg problem, but in order to find the entire hypotenuse, you just had to call it x plus 21. That would be the entire hypotenuse. And then when you go to cross multiply, you end up getting a quadratic equation. So I got x squared plus 21x equals 100. I subtracted 100 to get my equation in standard form, and then I factored it to x plus 25 times x minus 4. And I knew that I would get 2 answers since it was a quadratic, but I crossed off the x equals negative 25 because I know I can't have a negative side length. So it always has to be the positive answer. So x equals 4 is the final answer for number 8. Number 9 was a leg problem. And again, the entire hypotenuse would be equal to 5 plus x over 12 equals 12 over 5. Cross multiply, you get kind of a weird answer. I left mine as an improper fraction. X equals 119 over 5, which I believe is 23.8 if you wrote it as a decimal. Number 10 is very similar to number 8 because it's a leg problem and you end up getting a quadratic equation that has to be factored. I crossed off the negative answer, so the final answer for number 10 is x equals 4. So sometimes you will get those quadratic equations in there. And now hopefully you have a better idea of when to use these altitude on hypotenuse theorems and how to set them up.